Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between predictive analytics and prescriptive analytics. Primary question, predictive analytics, what will happen, forecast future outcome. In prescriptive analytics, what should we do, recommend optimal action, focus, probability of future event or future value. Prescriptive analytics optimize of decision to achieve a desired outcome. Output in predictive analytics, a probability score, a risk score, or a continuous value, the forecast. In prescriptive analytics, a specific actionable recommendation, the optimal decision. Techniques, predictive analytics, regression, classification, time series, forecasting, ML models, prescriptive analytics, optimization, algorithm, simulation, decision science, graph analysis, and reinforcement learning. Goal, predictive analytics to predict the outcome as accurately as possible. Prescriptive analytics to influence the outcome by recommending the best course of action. Dependency, predictive analytics, prescriptive analytics often use the output of predictive analytics as an input. Prescriptive analytics independent though benefits greatly from prescriptive input. Complexity. Predictive analytics moderate to high complexity requires robust forecasting models. Prescriptive analytics highest level of complexity required modeling not just the outcome but the impact of the decision. Business value. Predictive analytics provide foresight to understand the future state. Prescriptive analytics provide guidance for optimal resource allocation and strategy. Moving question, difference between data mining and data warehousing. Primary goal to describe hidden pattern, correlation, and knowledge from the data. Data warehousing to store, organize, and integrate data from various sources for analysis. Focus. Data mining, pattern discovery, and knowledge extraction. Data warehousing, centralized data storage and structured queries. Data state, data mining operates on the process and clean data typically stored in a data warehouse. Data warehousing operate a raw historical and integrated data from operational system. Nature of activity. Data mining, dynamic, iterative, and exploratory process of analysis. Data warehousing, static, structural, and supporting the data mining BI process. Output, data mining models, rules, clusters, decision boundaries, actionable intelligence. Data warehousing, clean, consistent, and aggregated data ready for querying and environment. Data volume, data mining often work with subset or sample of data pulled from for analysis. Data warehousing store massive volume of historical time variant data. Key techniques, data mining, classification, clustering, association, rule mining, regression. Data warehousing, ETL, ELT processes, schema design, star, snowflake, data modeling. Query type, data mining, complex analytical queries to test hypotheses and discover patterns. Data warehousing, standardized summary queries and BI reporting queries. Moving question, difference between ETL extract transform load and ELT extract load transform. Order of operation, extract transform load and extract load transform. Transformation location, in ETL, transformation occurs outside the target database, typically on separate staging server. In ELT, transformation occur inside the target system, example data lake, cloud, data warehouse. target system historically suited for traditional relational data warehouse with limited compute. ELT is suited for modern cloud data warehouses, example Snowflake, BigQuery, and data lake with high compute power. Data stored ETL only the transformed and aggregated data is loaded and stored in the warehouse. ELT all raw data is loaded first and stored. Transformation are performed on demand. Implementation ETL requires upfront planning of data requirement and transformation rigid schema. ELT offer greater flexibility. Schema on read is possible. Transformation can be changed later. Initial loading speed. Slow loading due to transformation step occurring before the load. ELT faster loading as data is loaded raw, leveraging the target system speed. Cost driver. ETL cost is primarily driven by the separate transformation server tool. ELT cost is primarily driven by target system compute for transformation and storage. Latency. ETL higher latency for initial loading and all the data must be transformed first. ELT low latency raw data is available quickly. Moving question, difference between SQL and NoSQL. Relational database RDBMS and NoSQL non-relational database key value document graph column family. Schema predefined uh, fixed schema on write data must conform to the table structure. NoSQL dynamic flexible schema on read allow to fast change and vary data. Data structure in SQL data is stored in tables with rows and columns highly structured. NoSQL data is stored in documents, key value pair, graphs or wide columns, unstructured, semi-structured. Scalability. SQL primary scales vertically, upgrading server hardware difficult to scale horizontally. NoSQL scale horizontally, adding more commodities server to handle massive load. Transaction generally adhere to acid properties, atomic consistency, isolation, durability. For strong consistency, NoSQL generally adhere to base properties, basically available soft state, eventually consistent. For high availability. Query language uses SQL standard structured query language, declarative language for complex join and queries. NoSQL use unQL, unstructured query language or API-based queries, lack native complex joins. Best use case, SQL financial transaction legacy system applications require complex join and data integrity. NoSQL real-time web application, large volume of unstructured data, example log, IoT, social media. Example SQL, PostgreSQL, MySQL, Oracle, MS SQL Server, NoSQL, MongoDB, document, Cassandra, column family, Redis, key value, pair, and Neo4j for graph. Please like, subscribe, and share the channel. Thank you.